This is a video tutorial solution to the questions posed in assignment 5C for H1 Mathematics Year 5 2012. The topic is differentiation and applications thereof. The first question in this assignment gives us that sand is poured onto a flat surface and a right circular cone is formed. So that means I'm dropping some sand and as it hits the ground, it's going to form a cone. And a right circular cone means firstly that it's got a circular base and that the apex of the cone, the very highest point, is directly above the center of the circle, so that it's going to form a right angle. Now we also know that the height of this cone is always going to be, so the height h is always going to be twice the radius, so height is 2 times r. And the volume of the cone is increasing at a rate of 6 pi cubic centimeters per second. So what does that mean? The volume of the cone is increasing at a constant rate, so the change in volume with respect to time is constantly 6 pi cubic centimeters per second. So the first thing we have to find is the rate, find the radius of the cone 24 seconds after the start of pouring. Well, we can assume that before we started pouring there was no salt on the there was no sand on the table. So assume no sand on table at the start. So that means that before we start pouring sand we've got a perfectly flat table. So what do we want to find out? I want to find out what is the volume I want to find the radius 24 seconds after doing that. Now I know that the volume of a cone, I don't have any way to calculate the radius of the circle directly, but what I can calculate is how much volume that this cone has 24 seconds later. And from the volume, and because I have a relationship between height and radius, I can work out what the radius of the cone would be. So the formula for volume is a third times base area, and the base here is a circle, so pi r squared times height. So in this case that's going to be a third, and then substituting in, a third pi, and then substituting in h is equal to 2r, I'm going to get 2/3 r cubed. So the volume is 2/3 pi r cubed. So what is the volume after 24 seconds? Well, the volume at t equals to 24 seconds is going to be the rate of change, which is 6 pi times 24. So the volume of this cone is going to be 144 pi cubic centimeters. So if that's the volume, what is the radius? The radius of the cone is then going to be, so we just use this formula down here, 2/3 pi r cubed is equal to 144 pi. So straight away our pi's cancel off. I multiply 144 by 3/2 and I get 216, so r cubed is equal to 216, and I take the cubic root of that, and I get r is equal to 6. So therefore 24 seconds after pouring starts, the cone has radius 6 cm. So part B wants us to find the rate of change of the height at this instant. So we're asked to find dh by dt. Well, this is quite hard to do dh dt when time is 24 seconds, or alternatively when the radius is 6, it's the same thing. So how am I going to find dh dt? Well, I've got dv dt, that's fine. And to get dh dt, I'm going to need to multiply by dh dv. And of course we've got a very nice theorem that tells us that dh dv is just the same thing as 1 over dv by dh. So what is dv by dh? Well, what is v in terms of h? Let's rearrange this so that it says r is equal to h over 2. That means that my volume is actually going to be 1/3 pi r squared h is equal to 1/3 pi h over 2 squared h is equal to 1 over 12 pi h cubed. So dv by dh, differentiating this expression, what do I get? I'm going to get 1 over 4 pi h squared. So the rate of change of height with respect to time, when time is 24, the radius is 6, so therefore my height is going to be 12, right? Because height is twice the radius, which is what we were told over here. So the rate of change of height with respect to time, when the height is 12 cm, is going to be dv by dt, which is 6 pi, divided by dv by dh, which is 1 over 4 pi, and then substitute in h equals to 12, so 12 squared. So this is 6 pi over 144 divided by 4, 36 pi. So you can see quite a bit of cancellation goes on here, certainly the pi's, and then I'm left with 1 over 6. And we conclude, therefore, the rate of change of height is 1 over 6 cm per second.